So tomorrow you have a quiz on 3.1 through 3.3. It's always at the top of your notes, so you'll know what's what ISM pages to go look at. Today you're going to have another assignment. You're only doing the evens, okay? And you have another delta math, because I like this stuff in delta math. Yes, sir? No, we're going to, oh, that's wrong. We're going to homeroom. I'm sorry, I need to fix that. But there's delta math. It's a little bit different than the way not that most, I think it's on evens. But one yesterday, there are, so let's say that there's 5 questions and you get to number 4 and you get it wrong, but you get 2 shots until you get it wrong. It's not just going to make you do number 4 again, it's going to knock you back to number 3, but it's a different question. On today's, if you're on number 4 and you get it wrong, it knocks you all the way back to 0. So basically you got to get 5 right in a row, okay? But there's 5 of each on the simple, quick ones, and then there's 3 of each on the ones that are not really that hard. The delta math stuff is just a little bit of practice, but I like this stuff, and when we get to other material, it's going to be good practice. Because it's on the doesn't mean you can write stuff down. Okay, like it's fun to write stuff down. But because of that, you're only doing the evens on the worksheet. We may get to where we just do a delta math, or maybe a few on the paper or whatever. But right now, I'm going to kind of keep it both, just so I can make sure that you're actually doing some work. All right, so we're going to actually start with properties of logs, which is going on page 69, which is not that, it's this. And this will be a total review if you were in pre-AP Algebra 2 last year. It will most likely not be a review if you were in on-level. It's probably going to seem brand new to you. All right, so we have a few properties so that we can combine, or that we can condense and expand logs so that we can work with them a little bit better. The first one's called the product property. So if I have some log of some base of 2 things that are multiplied together, then I can split them up. Notice that this is not 2 logs multiplied together. This is a log of one thing where 2 things are being multiplied. I can expand that into log base b of m plus log base b of n. And I should be able to use that property there to condense or expand. I can go in either direction. So if I look at number 1, if I'm adding these, I can condense them, and this can become log base 3 of 9 times 5. So this is log base 3 of 45. And that's the condensed form. So then number 2, this would become a log of 6 times x minus 3. That becomes a log of 6x minus 18. Works the same for natural logs because they have the same base. So this is going to give me natural log of 4x squared times 3x cubed. And then what's 4x squared times 3x cubed? 12x to the 5th power. Very good. Okay. They might. And if I get the bases that are different, then I can't combine them. Does that make sense? So if this was log base 2 and log base 3, then that is as simplified as I can get it. It's a good question. And notice on 1 and 3, I don't need parentheses, but I need parentheses on number 2. So make sure that you use them for the argument when you need it. All right, so then we can expand. So in order to expand, on some of the expansion ones that we're doing on the front here, there's more than one answer. Because I need to come up with 2 numbers that multiply to give me 72. Well, there's lots of options right there. 12 and 6, 9 and 8. I heard 12 and 6 first, so we'll go with that. So if I make this into log of 12 times 6, then that's going to give me log of 12 plus the log of 6. Now, when you would actually need to use this in what you're doing, you would probably have a goal in mind. Like, if I was trying to come up with, I needed a log of 8 to cancel out somewhere, then if I expanded that, then I would probably use 9 and 8 in that case instead of 6 and 12. But we don't know, so, I mean, I could do 2 and 36. There's a lot of options there. So even on the assignment, like, you could have more than one right answer, and it's fine. All right, so number 5, I need 2 numbers that multiply to give me 9/10. Well, it'd be really easy. 9 and 1/10, okay? Oops, sorry. Log of 9 times 1/10, I mean, that's fine. We don't have to get fancy, right? So then this becomes the natural log of 9 plus the natural log of 1/10. So what do I need to do on number 6? Factor, yes. So that factors into what?
X plus
2. There you go. So when I do that, now I have these two things being multiplied. So log base 5 of x plus 2 plus log base 5 of x minus 2. And there you go. Okay? We good? Yes? All right. So that is the product property. Let's talk about the quotient property. So now we're dividing. So if I have the log of some base of two things being divided, well, if when I multiplied, I added, what do you think I do here? Subtract. Log base b of m minus log base b of n. Yes, except we were using the product property. Well, on number 5, if we were just doing number 5 in general and it just said expand, then yeah, I could have used the quotient property. I could have done a few things there, but we were specifically using the product property there. All right, so then this here, I'm subtracting two logs with the same base, so this is going to give me the natural log of 96 over 6. What does that become? 16. There you go, 16. All right, so then log of 8x to the 10th minus log of 4x squared is going to give me log of 8x to the 10th over 4x squared. It's going to be log of what? 2x to the 8th. Okay. We all good with that? Yes. All right. So then here, subtracting, we have the same base. So we'll get log base 7 of the square root of 40 over the square root of 5. Can I divide 40 by 5? I can, because they're both under the square root. So this becomes log base 7 of the square root of 8. Can I simplify that? Yep. Log base 7 of what? 2 square roots of 2. There we go. All right. Then I'm going to expand using the quotient property. So here I need two numbers that are going to divide to give me 8.
64 and 8.
Okay, we'll do 64 and 8. This is equal to the log base 3 of 64 over 8. So that gives me log base 3 of 64 minus log base 3 of 8. All right. Then 11, natural log of 3/4 could very easily become the natural log of 3 minus natural log of 4. And here, log of x minus 7, got to have parentheses there, minus the log of x plus 1. And you're good. Okay. What questions do you have? Anything? All right, so that's the quotient property. Now let's look at the power property. Is this 3, 1 through 3, 3? No. All right, so the power property, log base b of m to the nth power. So these exponents of the argument of the log, like whatever you're taking the log of, that exponent comes out front. So it's n times the log base b of m. This says condense into a single logarithm, simplify if possible. So since this is out front, it comes up as an exponent, and this gives me the log of 6 to the 3rd power. What is 6 to the 3rd power? 216. There you go. Then I have, this becomes log base 4 of 81 to the 1/2 power. So what's 81 to the 1/2 power? Just 9, yeah. Just the square root, just 9. Then this is going to become the natural log of 4 to the x minus 1 power. Is there anything else I can do with that? Nope. That's it. So now we're going to expand. I'm going to take, this is log base 2 of 5 to the x power, so x comes out front. This becomes x times the log base 2 of 5. And I'm done. Cube root can be rewritten how? 1/3. So this is like the natural log of 2x plus 1 to the 1/3 power. Very good. And make sure you have parentheses around the 2x plus 1. All right. So then I have log base 6 of 1 over 64. And I'm supposed to be using the power property because it specifically says to expand using that. So how do I get 64 out of the denominator? -1. So this is the same as log base 6 of 64 to the -1 power. So this becomes negative log base 6 of 64. Me too. All right. How are we doing? We good? All right. Now pick up the reference sheet. We're going to go through that real quick so that you can keep that handy and not have to flip back and forth if you need to. This is going on page 68 when we're done. So a couple of things. It says common logarithm, a base 10 logarithm written as just log of x. So you don't have to put a base there. A natural logarithm, base e logarithm written as the natural log of x. Okay. So some basic properties here. Log base b of 1 equals blank. Okay? So you can think about when you graph a log, see if you can picture the log graph in your head, because you should be able to. We did them at the beginning of the year with our parent functions. A log is the inverse of what? A log is an inverse of what? No.
Honestly, I don't know, but I know the answer has to be 0.
Okay. Well, hang on. It's of an exponential, okay? It's of an exponential. So a log is an inverse of an exponential. You have to be able to picture these graphs and think through this stuff in multiple different ways for multiple different reasons. If an exponential function looks like this, right? There's your exponential. And this point is what? 0, 1. The inverse, when you take the inverse, it gets reflected in the line y equals x, right? So your log graph looks like this. So what's that ordered pair? This is 1, 0. This is 1, 0. This is 0, 1. Okay? So when x is 1, y is 0, no matter what the base of the log is. You need to know that graphically, and then you also need to be able to reason through it over here. B to what power gives me 1? 0. Okay? I know you told me that, but you told me that. Why did you know it had to be 0?
Because I flipped them, and I knew that it has to equal 1.
Okay. No, that's good. And that's what I said here. You got B to what power gives you 1, so that's good. But you also need to be able to think of it from a graph too. So like all those different things need to kind of come together, picturing your graphs and knowing what's happening with them as well. All right, so what about log base B of B equals what? What does that have to be?
1.
So B to the x power equals B, so x has to be 1. Those two things, very basic. You need to know them so that they don't cause you too much stress in your thought process while you move through other things. But just think of it as an exponential. B to the 0 power equals 1. B to the first equals B. So you know which one has to be 0 and which one has to be 1. Okay? All right, so log base 6 of 1 has to equal what? 0. And the log base 4 of 4 has to equal 1. Okay? See how easy those are? Like those are things we should be able to calculate pretty easily. All right, so these are the properties we just talked about on the other page, but just trying to get them all on a little reference sheet here. My product property, when you're multiplying those two, that becomes log base b of m plus log base b of n. Oh, I don't guess I need a box around it. Whatever. All right, so then when I'm condensing these two, the bases are the same, so I get log base 3. And I'm going to multiply those two. What's 3x times 8? 24x. in order to expand this, what am I going to have to do with that? Factor it. So the natural log of, and then this factors into two binomials. What does it factor into? Good. X minus 2x plus 1. So then this is going to give me the natural log of x minus 2 plus the natural log of x plus 1. Everybody okay with that? All right. So then we have the quotient property. We're dividing, so we're going to subtract log base b of m minus log base b of n. So here when I condense, this becomes the log of 80 over 16, which becomes the log of 5. And then to expand, this just becomes log base 2 of x minus log base 2 of 5. Everybody okay with that? Yes? All right. So then, power property. Log base b of m to the nth power, n times log base b of m. So when I condense this, this becomes the natural log of 9 to the third power. What is 9 to the third power? And then when I expand this, this becomes 2x times the log base 7 of 3. We good? Yes. All right. So then the change of base formula. That was actually from yesterday, but it's still something we need to know, so it's kind of all together. This becomes log of a over log of b. So to evaluate these, we'd get log of 138 over log of 5. Does that mean I can change it into subtraction? No, because when you're dividing, notice how this is the one log of one argument that we're splitting up into two, not two separate logs. This you would need a calculator for, so I'm just going to give it to you because I know you know how to type them in, but we don't need it for anything else today. And then this becomes log of 2 over the log of 14. Does this become the log of 1/7? No. It's 0.263. Because you don't get to just cancel those out. Yeah. All right. What questions do you have? Anything? Yes. All right, so let's go back to the other piece of paper. You can keep that reference handy, so if you need your properties, they're right there. You don't have to flip back and forth. So we're going to condense each expression into a single logarithm. Now I'm going to skip some steps here because I think you should be able to do that at this point because you can think about it before you just jump in and start writing stuff down. This is going to be, since this is out front, this 2 becomes an exponent on the 9, right? And the 3 becomes the exponent on the 2. And then since I have 2 logs of the same base, I'm going to be able to multiply those two things together. So that's going to give me log base 4 of 9 squared times 2 to the third power. And I could have gone ahead and done 9 squared and 2 to the third power, but just want to make sure I didn't lose anybody just yet. So log base 4 of 81 times what? 8. And then what is 81 times 8? 648. Okay. Everybody okay with that? So here I'm subtracting 2 logs with the same base. So this is going to, so I'm going to divide. So it's going to give me log of 80 divided by, well, that 2 becomes an exponent on the 4. 4 squared is 16. So this is the log of 5. Okay, so here, the 3 is going to become an exponent on the p times q. 4 becomes an exponent on the p times q squared. So we're going to have the natural log of p times q to the third power plus p times q squared to the fourth power. Right? Could have skipped that. I could have skipped a step in here, but I didn't want to lose anybody on this because I want to make sure you understand your exponent rules, your whole power to a power rule. Bless you. Oh, this shouldn't be plus. I'm sorry. What should that be? Times. Dang it. Actually, I don't even need anything there. I could have just squished them together, but since they're so far apart, I'll put that in there. So we know what's going on. We multiply them, and that's what I meant to do. I put plus, I didn't mean to do it. Oh, yeah. Oh, yeah. Power to a power, you're multiplying. So this becomes the natural log of p cubed times q cubed times p to the 4th times q to the what? 8th. And then I can combine those. So I get the natural log of p to the what? 7th times q to the 11th. Everybody okay with that? Good. What questions do you have? Anything? Stop me if you have a question if I lose you. Okay, you guys speak up. All right, so here's my suggestion when you have parentheses and you are condensing, is I would work from the inside out. Don't take that 1/2, and I can't make it an exponent on this thing right here anyway because this isn't a log. So I just going to leave the 1/2 out front and take care of stuff in here. So this is going to give me 1/2. Now I've got 2 logs that I'm adding, so I get to multiply. This is going to be log base 5 of x to the what? To the 9th, because there I add the exponents, right? Now I have 1/2 times a log, so that can become an exponent. So this is going to become log base 5 of x to the 9/2. How else can I write x to the 9/2? Oh my God, not 4.5. Square root of x to the 9th, yes. Have you ever changed a fractional exponent to a decimal? No. This is what it would look like right here. What questions do we have? Anything? All right. 2 logs, same base. We always want to check that, right? And I'm subtracting, so I'm going to be able to divide. So I'm going to make this the natural log of 64 to the 2/3 power over 8 to the 2nd power, which is 64, right? Okay, so do I get to... No. I cancel out the 64s, right? But what could I do? I could simplify. Well, I could simplify, that's pretty broad. If I had x to the 5th over x cubed, what would I end up with? X squared, and how do you get that? By subtracting the exponents. So can I subtract the exponents here? They have the same base. What's the exponent in the denominator? 1. So what's 2/3 minus 1? Negative what? 1/3. Yeah, negative 1. Subtracting exponents, just like we would have here. To simplify it. Otherwise, I'm not done. I can't cancel the 64s out because they have different exponents on them. So that negative 1/3, what does the negative do to it? Reciprocal. So I could make this into the natural log of 1 over 64 to the 1/3 power. Anything to the 1/3 power? Yes, but I was going to, Ruth needs me. I can, or if you're going to do B, I'll get Jill. Jill, I'll ask Jill this one. Okay, thank you. Okay. No, because we are condensing. That would be expanding. What does 1/3 mean? What's something to 1/3 power? The cube root. So I'd need the cube root of 1 over 64. So that's easy if I can just figure out the cube root of 64, right? What's the cube root of 64? 4. So this is equal to the natural log of 1/4. Everybody okay with that? All right, good deal. So number 24, again, we have parentheses, so we're going to work from the inside out. And I really want to figure out, I don't know why my border keeps disappearing. I can't pause. All right, so I'm going to work from the inside out. I'm going to leave this negative 2 out here. And so this will give me the log of, this is going to be 15 times 1/9 to the 1/2 power, right? So what is 1/9 to the 1/2 power? Square root of 1/9, which is 1/3. And then 1/3 times 15 is what? 1/3 times 15? 5. Okay. So this is going to give me negative 2 times the log of 5, basically. So that gives me log of 5 to the negative 2 power. And what is that? 1 over 25. And there you go. All right, what questions? Anything? Okay, we're just going to practice some more, getting through these. Now, on 25, I've got parentheses, so I'm going to take care of those first. I'm going to leave the log of 72 alone. So I'm going to get the log of 72 minus 1/3 times the log of, well, this is going to be 4 squared, so it's going to be 16 times 32, right? So what is 16 times 32? Y'all agree with that? If not. What's 32 divided by 2? 16. So isn't this the same thing as 16 times 16 times 2? You know what 16 squared is? What's that? 256, and then you double that and you get 512. So this is equal to the log of 72 divided by 512 to the 1/3 power. Where did I lose you? If you write out every single step on this, you're going to be writing a lot. You can, but I don't know that it's necessary. So 512 to the 1/3 power, what does that mean that I need? Cube root of 512. So again, this number sense comes into play. If I can rearrange these numbers to make it easier, I can maybe still, this is the same numbers, I can rearrange them again. Isn't 16 the same thing as 8 times 2 times 8 times 2 times 2? What's 2 times 2 times 2? 8. So isn't this 8 times 8 times 8? What's the cube root of 512? 8. You have to not be afraid to just write numbers down and kind of play with them and see how they work with each other, and you end up with the log of 9. Okay. What questions do you have? Either that or you have to sit there and guess and check and figure. I mean, you can find the cube root by doing the factor tree just like you do a square root. You just have to look for groups of 3 instead of groups of 2. I mean, it works, but. All right, so here we are subtracting. So we are going to end up with division. So this is going to give me the log base 3. In the numerator, I will have a to the 3/2 power divided by, well, this will be 16 to the 1/4 power times a to the, what's a to the what power? What's the exponent? 1/4. 1/2. Okay, 1/2. So then I use my exponent rules, and what do I end up with in the numerator? A to the 3/2. 3/2 minus 1/2 is 1. So it's just a. And then 16 to the 1/4 power is? To take the 4th root, you take the square root and take the square root again. So it's 2. Okay, we good? What questions do you have? Because 3/2 minus 1/2 is a positive 1. So it ends up on the top. Yes, it has nothing to do with PEMDAS. But okay. All right, so now that's condensing. Now let's expand. I didn't cancel them out. I did a to the 3. I had to do 3/2 minus 1/2. That gives you 1. Just like up here, you would do 5 minus 3 to give you x squared, right? It doesn't just work with whole numbers, it works with everything. So I do 3/2 minus 1/2 gives me 1. So I'm left with a to the 1st power.
Oh, so 16 to the 1/4 times 1.
It's what?
16 to the 1/4 times 1.
Times 1. Oh, well, yeah. So you're saying this turns into a 1? Yes, okay. Yes. That. All right, so now we're going to expand, right? We're going to expand. We're going to be British. We're going to expand these. So we have to keep that log base 7. They're being multiplied, so we're going to add the 2, and then we got an exponent. We can do this all in one step. So this can be log base 7 of x plus 3 times log base 7 of y. And we're done. 28, I'm dividing, so it'll be subtraction. So this will become 3 times the natural log of m minus 7 times the natural log of n. Everybody okay with that? Yes. All right, so I would change this to the 1/2 first. And so this is going to be equal to the log of a cubed times b to the 1/2 power. Okay. Now you got a couple of options here. I could bring the 1/2 out in front and then take care of it that way. But what's going to happen is I'm going to have a 1/2, then I'm going to have to leave everything in parentheses until the end. And in the end, you end up distributing anyway. It's way easier to go ahead and distribute the exponent now. And so to go ahead and make this log of a to the 3/2 power times b to the 1/2 power. Then expand it. That way you won't have parentheses that you'll have to deal with. So I'm multiplying those two, and the exponents come out in front. So this will give me 3/2 times the log of a plus 1/2 times the log of b. And basically, if we hadn't done that, we'd end up with a 1/2 out front, and then we'd have 3 log a plus log b. Then we'd have to distribute the 1/2 anyway. You end up with the same answer. It's just easier that way. So same thing here. I could go ahead and bring the 4 out to the front, but then that means I'm going to have to keep some parentheses in there. Instead, I would go ahead and take care of that exponent and make that log base 4 of c to the 8th over d to the 4th. Then expand it. Okay? So this will give me 8 times log base 4 of c minus 4 times log base 4 of d. What questions do you have? All right, so then I want you to do 31. Well, you can, but if you combine them, you're going to end up dividing, and that's not what we're trying to do. If this was log base 4 of c and log base 4 of c right here, then I could actually combine them into one term. But we're expanding them. Thank you. Dang it. I would have really confused myself in just a minute. There we go. Q to the 8th. So this can give me So either one of those would work. It kind of depends on whether or not you leave that 5 squared or if you make the 5 squared 25, but both of those would be acceptable. Okay? All right, so let's look at 32. So I want to take the root and make it into an exponent. So this is going to give me log base 2 of x to the 1/3 power over, and then I need to factor this. This becomes x times what? X plus 1. Okay? So I'm going to have, I'm going to go ahead and, when I separate all this out and expand it, this will give me log base 2 of x, and then the 1/3 comes out front. So again, 1/3 times log base 2 of x minus, and then I need parentheses here because I'm subtracting the whole denominator. This is going to give me log base 2 of x plus log base 2 of x plus 1. Okay? So minus everything in the denominator, and then I have to distribute that negative sign. So this will give me 1/3 log base 2 of x minus log base 2 of x minus log base 2 of x plus 1. Okay, make sense? Because you have to it's being divided by both of those things, so they're both subtraction. Now, there's one more thing I can do here, which is kind of condensing, but really it's anytime you can combine like terms, you do that whether you're condensing or expanding anyway. Can I combine like terms? Whatever x is, isn't log base 2 of whatever that number is the same as log base 2 of whatever that number is? So if I have 1/3 of this minus this, what does that leave me with? Negative 2/3. So this will give me negative 2/3 log base 2 of x minus log base 2 of x plus 1. Uh-huh. You are expanding, but we're still combining like terms. That was the first time we can combine like terms. You don't just, to expand, you don't just like, you know, space out everything you possibly can. Yeah. Okay, we good? What questions do you have? Awesome. All right, when I hand you the assignment, are you doing the entire paper I give you? No, just the evens. Good. I can't. Let me go pause this first. Oh, no. Oh, click here to pause.